In the vast realm of physics, motion is a fundamental concept that pervades every aspect of our existence. It's a dance that objects perform, whether inanimate or living, as they traverse time and space. Today's journey will delve into the wonders and complexities of motion, inviting viewers to understand the principles that dictate how everything moves and operates in our universe. Our exploration begins with a core concept of motion, defined as the change in position over time. Motion is seen in everything around us, from the elegant movements of the planets revolving around the sun, to the rhythm of a heartbeat, to the intricate ballet of electrons within an atom. It is a pivotal element of mechanics, studied systematically through Newton's laws, which form the foundation of classical mechanics. The first stop is Newton's first law of motion, stating that an object will remain at rest or in uniform motion unless acted upon by an external force. This law introduces the notion of inertia, the resistance of any physical object to any change in its state of motion. Through vivid animations, viewers will experience how inertia plays a role in both celestial and earthly interactions. Next, delve into the second law, which posits that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. This offers insight into how the universe manages conflict and resolution, providing guidance on how force and mass interplay to produce movement. The journey continues with Newton's third law of motion. For every action, there is an equal and opposite reaction. Through compelling visual experiments, witness scenarios such as rocket launches and sporting events, where action-reaction dynamics are at play, amplifying the significance of forces in motion. As the exploration progresses, the video examines types of motion, such as linear, rotational, and oscillatory. Discover the grace of pendulums, the symmetrical spin of rotating wheels, and the oscillating patterns of springs. Each motion type will be showcased with specific examples, enhancing understanding through clear, real-world applications. The adventure takes a detour into the world of kinematics and dynamics, dissecting complex equations and graphical representations that describe how objects move. Through expert interviews and animated diagrams, viewers will gain a deep appreciation of velocity, acceleration, and the trajectories that objects follow. Further exploration includes the allure of celestial motion, unraveling the mysteries of how stars, planets, and galaxies move within the cosmos. The narrative will unfold the laws of universal gravitation that Einstein expanded upon, revealing gravitational waves and their profound impact on space-time. The video opens with a brief explanation of motion, a fundamental concept in physics, and its significance in the natural world and technologies. A montage of natural phenomena and technological inventions illustrates various types of motion. The video delves into linear motion, where an object moves along a straight path. It explains uniform and non-uniform linear motion, kinetics, and real-life examples like cars on a straight highway, birds flying straight, and athletes running. Next, the focus shifts to circular motion, where an object moves along a circular path. Both uniform and non-uniform circular motions are elucidated. This section includes detailed examples, such as planetary orbits and applications like centrifuges and merry-go-rounds. This chapter investigates projectile motion, highlighting its two-dimensional nature and the influence of gravity. Examples include throwing a ball, water from a fountain, and basketball shots. Physics problems involving initial velocity, angles, and range are solved to show practical uses. The documentary explores rotational motion, where bodies spin around an axis. Explanation with everyday examples like wheels, Earth's rotation, and frisbees is provided. Discussions cover angular velocity and rotational dynamics. Oscillatory motion features prominently, such as the back-and-forth movement in pendulums and springs. Concepts like amplitude, frequency, and period are detailed, coupled with demonstrations of simple harmonic motion in clocks and musical instruments. The complexities of combining translational and rotational motions are analyzed. Real-life examples such as bicycle wheels and rolling coins are illustrated. Physics principles of energy conservation in these motions are explained with simulations. This segment covers less typical motions, diving into helical motion and complex fluid dynamics including turbulent and laminar flows. The chapter uses advanced scientific visualizations to engage viewers. The video concludes with a summary of the presented concepts, emphasizing the relevance of comprehending different types of motion in everyday life and future technologies. Experts give final insights into how studying motion aids in solving modern challenges in engineering and science.